For this video, we're going to talk about an example where we're going to use Descartes' Rule of Sign to determine the possible number of positive and negative real zeros. So in order to find how many positive real zeros that we could be looking at in solving this polynomial equation, what we need to do is we need to count how many sign differences we have in each term. For example, if we look at our first term is negative. And from negative to positive, that is a sign change. So I'm going to count that as 1. From our next term, we go from positive to negative. So that's also another sign change. So that gives me another one. Then we have negative to positive. So that gives us a third sign change. And we go from positive to negative. So there goes a fourth one. There was 4 different changes in sign throughout this equation. So what the rule for positive zeros says is that we either have 4 positive zeros or multiples of 2 less than that until we get to 0. So 4, 2, 0. We would either have 4, 2, or 0 positive real zeros if we were to solve this equation. And so that's our positive zeros. In order to figure out how many negative real zeros we will have, what we need to do is we need to plug in negative x for x and do the same thing. Count how many changes in sign we have. So if we plug in negative x for x, this is what it's going to look like. Okay, so when we simplify this, remember that this negative x raised to the 4th power is going to become positive. So this is really just negative 4x to the 4th. This one here, negative x cubed, will make this now negative. So negative 8x cubed. The negative x squared will become positive. So we drop down the minus 7, and that will be a positive x squared. Then we have minus 4x and minus 4. So we need to do the same thing, go through and see how many sign changes we have. Well, negative to negative is the same. To negative is the same, and we see that it's all negative. We don't have a single sign change. So that means there would be 0 real negative zeros for this polynomial equation.